Hey guys, this is a quick refresher on area and circumference of a circle. I've got the equations up here, the formulas, right off the bat that you can look at just so you need to memorize these, okay? Now, we've talked about why they work, how they work, but as long as you trust that they work now since you've seen it, these are all you really need to know about circles, that these formulas work every time, okay? So circumference can be pi times diameter. D stands for diameter. Now remember, on a circle, diameter is all the way across, right? Well, diameter is also equal to 2 of the radius, because a radius is from the center out to the edge, which is only half the diameter. You need 2 of these radiuses to get to the diameter, right? So you could say circumference is equal to 2 times pi times the radius, because you need 2 of the radius to get to diameter. So those are saying the same thing, okay? Area is a little different. Remember, area is pi r squared, okay? Which is not the same as 2 pi r, okay? Now remember, you need to square the radius before you multiply by pi. That's a mistake a lot of people make, okay? So that's order of operations. Exponents comes before multiplication, right? So you could rewrite it, if it helps you see it a little better, pi times r times r. Okay, that way you don't really have to worry about exponents. You just straight across multiplication at that point. Okay? So we also talked about how there's always a proportional relationship between circumference and diameter. Well, when you take circumference to the ratio circumference to diameter, that always equals the same constant, pi. And it's very, very similar to, remember when we were working with proportional relationships, y equals kx, where k was the constant. Now that was a long time ago, as towards the beginning of the year, but we have done this, y equals kx, where k is the constant, right? Well, that's the same thing in circumference. Pi is now the constant, that is the k. C is the same as y. D is the same as x, right? So the independent variable is this x and this d. The y is the dependent, same as circumference. Y depends on what you put in for x. Whatever you put in for x, you multiply by the constant. For example, y equals 5x. Well, you can make a chart. Okay, you could put 1, 2, 3 in for x. Well, when you put 1 in for x, 5 times 1, y would be 5. 2 in for x, y would be 10. 3 in for x, y would be 15. Okay? Well, it's the same as this equation for circumference. C equals pi times diameter. What number is never going to change? Pi. That's your constant. It's constantly pi. Diameter can change. If diameter changes, then circumference changes, because you're multiplying a different number times pi. Alright, so that's a quick recap on the equations, formulas. Now remember, the reason pi r squared is the formula for area of a circle is because when they took that circle, remember, and they split it up into triangles, right? Well, then they took half the triangles, put them along the top, took half the triangles, put them along the bottom. When you make a really, really, really small triangle instead of these bigger triangles, okay, you end up getting half the circumference up here, right? So that would just be 1, 2, 3 of them, that half there, right? And then the other half, the circumference, is down here. Well, we know area of a rectangle is base times height. Well, the base, remember, is 1/2 of the circumference, like we just said. Well, if circumference equals 2 pi r, then half of the circumference, instead of 2 pi r, you're just going to have pi r. Okay? So with this rectangle, your base is going to be just pi r. And then we talked about the height as well. We know it's base times height to get area of a rectangle, which is what we turn the circle into. Well, the height is just the side of one of these triangles right there. And you notice the side of one of the triangles, this same height here, is just the radius. So that's how you get pi r squared, because you're taking base times height. Pi r times r. Well, pi times r is the same as pi r squared. That's where the area comes from. Okay, so let's just work a few quick ones here. Alright, let's say we're going to do circumference and area. Okay, now let's say the radius is, let's go with 8. Okay? Well, circumference is pi times diameter. We do not have diameter here. We've got a radius. We need 2 of those radiuses to get the diameter. So it's actually 16 pi, right? Or pi times 16. Now, if they tell you to leave your answer in terms of pi, meaning like you're not going to have a calculator sometimes, they'll just say leave your answer in terms of pi. This is your answer, okay, just 16 pi. If they tell you to use 3.14 for pi and multiply it out, then you just take 16 times 3.14, and you get 50.24. So that's the circumference. Remember, circumference is just distance around the circle. That's the whole distance around this circle. Okay? Area is everything inside of it. All this. Okay? So area, remember we just talked about, is pi r squared. Or pi times r times r. Okay? So we've got pi times 8 squared, which is pi times 8 times 8, which is 64 pi. If they tell you to leave your answer in terms of pi, that's your answer. If they tell you to use 3.14 for pi, your answer would be 200.96. Okay, that's your area. Okay. Now, they might have you do something crazy, so let's, since it's about sectional time here, we'll do a basketball example. If you look at a basketball court, this is the free throw line, and then so the lane down here, and then they've got that little half circle, right? Well, let's just, I'm not for sure exactly how long the free throw line is. Let's say it's 10 feet. Okay? Now, from the free throw line to the goal is 15 feet. Okay? So, what if they tell you to find the area of everything inside the lane, including this semicircle? Okay? Well, this comes back to like the area of composite figures or composite shapes. Well, we already know the area of a rectangle, right? We know that one by heart. Length times width, base times height, whatever you want to call it. Okay? So, break it into shapes you do know. This rectangle is 10 times 15, which is 150 for the rectangle. You still need to find the area of this semicircle. Okay? Remember, area of a circle is pi r squared. Right now we have the what? We have the diameter. Okay, so we need to do area equals pi. What's the radius? If the diameter is 10, the radius would be 5. Pi times 5 squared, which is 25 times pi, which is 78.5. So the area of the semicircle is 78.5. Well, you need to combine that with the 150. Okay? You get 228.5. and that would be square feet, right? So that's the area of the lane and the semicircle above the free throw line. Okay? Now what if they did half court? Okay? Well, this is a full circle this time. And I believe half court would be about the same as the free throw line from this side of the circle to the other. I'm just guessing, but... Whoa, 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 whoa. Hold up. Hold up. Anybody catch my mistake? Alright, I'll give you a second to see if you can catch my mistake on this last one. Alright, we found, if you haven't found the mistake yet, you can pause the video and make sure you look for it. We found that the area of the circle would be 78.5, right? Well, do we have a full circle? No, we only have half a circle. So instead of 78.5, we need to split that in half. This would only be 39.25 feet. Now you add that to the 150 for the rectangle down below, all that, okay, and you actually get 189.25 square feet. If you caught that before I even said anything, great, good job. If not, I hope you see it now, okay? Make sure you understand that's only half of a circle, okay? That might come back to bite you in the butt. That's the whole reason I did that example. I don't know why I messed that up. Okay, so this other one, now we have a full circle, okay? And it's 10 feet across still. All right. So the whole diameter is 10 feet. Well, let's go ahead and find circumference and area of it. Circumference is diameter times pi, so 10 pi, which if you use 3.14, that'd be 31.4 feet all the way around the half-court circle. Area of this, okay, well, we just found that, right? Now it's the whole 78.5 square feet. Okay, now because we have the whole circle. All right, so be careful with that. Okay. So, another example real quick. So I know this is a bad drawing and actually a little bit bigger than they really are, but let's just say we have a stoplight that's 6 feet tall, okay? And the lights touch each other and touch the edges. So even though it doesn't look exactly perfect, just imagine that these lights, red, yellow, green, all touch each other and touch the edges perfectly, okay? And they want to know what's the area of everything that's not a light. So all the yellow on the normal stoplight. Not the yellow light, but the yellow like around the lights. Okay, what's the area of all that? Okay, well, it's 6 feet tall completely. So there's a few different things we've got to do. First off, if it's 6 feet all the way, then that means the diameter of each circle is 2, right? Now, before we start anything else, let's remember area is pi r squared. Okay? Well, if you notice an area, we need radius. So we've split it into diameters, but we still need the radius. So instead of 2, we need 1. So half the distance across one circle is just 1. Okay? So the area of one light is 1 times 1 times pi. Well, what's 1 times 1? 1. So the area of one light is just pi, right? How many lights do we need? We need 3 of them. So we're going to take pi times 3. And we get 3 pi. Alright? And if you multiply 3.14 times 3, you get 9.42. And that's square feet, right? Now, that's the area of the lights. They want to know the area of everything that's not the lights. Well, you might be looking at this rectangle and saying, well, we know it's 6 feet long, but we have no idea how wide it is. Well, actually you do. Since these circles touch from side to side, it's the same diameter as up and down, because it's a perfect circle, so the distance across is actually 2 as well. Okay,